So let's take a couple modeling questions, right? Let's try this first one. I'll call it out, right? Right, in mass in grams, the mass in grams of a piece of radioactive material, at time t years, right? So the first thing we see in mass in grams, time in years, right? Mass in grams, time in years. Is modeled by the following formula. M is equal to 6e to the minus 0.12 t. Okay, so we have this model equation here. This is used to model how mass change in time. Okay, all right. So first part, the present mass of a radioactive material. So the first part is they want to get the present mass. What is the mass at this point in time? What do you do? So the one the mass when t is 0. All right. So the one the mass when t is 0. So that'll be 6e minus 0.1 t to the 0. This is 0. E to the power 0 is 1. So the answer is 6 grams. So the initial or the present mass is 6 grams. Second part, part B. Part B, the mass present after 5 years. Find out if right, so all we're doing, we'll be using the modeling equation. M is equal to 6e to the minus 0.12. Time is in years, so you put 5. And that'll be something graph. How much? Amanda got 3.29. So when you use exponent, you're getting 3.29, right? So again, everything really comes from here. How do you do part 3 though? Time for the mass to reach half of the original value. Time to reach half of the original value. What are you gonna do? Well, kind of, yeah. So now the mass is what? What's the mass? 3. So the mass is 3. The formula is 6e to the minus 0.12 t. Half. Half of the original. Half of the original. I didn't write it here because I didn't want to go on this side. Right, yeah. Where the cell phone now? Solve for t, right? How are you going to solve for t? Really? Go ahead, have fun. Do that part. Well, what you have to do is take ln on both sides. Right? You can bring the 6 across if you want. You can bring the 6 across. And then when you reach here, what to do? Take ln on both sides. Because you get E here, right? So take ln on both sides. Ln here is equal to ln here. What is ln E? Ln E is 1, right? So you'll end up with ln of 0.5, whatever that is. Ln E will kind of cancel, you could say. So you will get minus 0.12 t. And then make t the subject. T is equal to minus 0.12 over ln 0.5. Yeah, you can bring the power rule there and then find ln E is 1, right? So technically, that's what I did. I took the power, bring it in front, to bring it down, and ln E is 1. Or you can say ln E of anything is anything. So ln E of 5 is 5, ln E of 3 is 3. So ln E of this is this. Right? That's technically what I did. How much you all got there online? Oh, I have it back to front. Oh, see that? I put this here. I put it upside down. Yeah, sorry. I wrote it the wrong way. Try one more like this one, just to get familiar with working with ln. Right? Find the time to reach. Time to reach 2 grams. Time to reach 2 grams. So you want the time to reach 2, right? So 2 is equal to 6 by e to the minus 0.12 t. Carry across this and take ln. So you'll get ln 216 is equal to ln e 0.12 t. Ln you cancel. You'll get ln 216 is minus 0.12 t. And you can easily solve for t. T is equal to ln 216 all over minus 0.12. 9.2, right? That will work. Let's go again. Find the present mass. Find the mass after 5 years. Right. So this is the modeling question. Present mass means when T is 0. So you're plugging in T is 0 here. 250 by a half to the power 0. And into the 0 is 1. So the answer is 250 grams. MIT too. No, right? M in terms of T. Alright, sorry. Fix it, please. Online, in case you do that, fix it, please. Right? If you see this, M of T, it simply means the function M is in terms of T. Right? Here's what now? 250 by a half to the power of 5. How much you got here? 7.8. 7.8. Right? Now, time for the mass to reach 125. Here's 125. Here is 250. By a half to the power of T. Alright, because 250 here. You will get 125 on 250. It's a half T. So a half is equal to a half to the T. So T is how much? 1. T is 1. But let's just say what the worst number. What would have done? Take logs on both sides. There we go. Right? So of course we could see it here that T is 1. Right, so given here B and T. T is in years. T is in years, and V is the value in thousands, right? In thousand. Right, so the equation I'm going to give you is VT. Huh? All right, because that's what you're going to see in exams. Right. 365 part 1, I would like the initial value and the time. Yeah. So find the time to reach $91.25,000, right? All right, so when T is 0, right? When T is 0, you'll get V of 0 to be 365 by e to the minus 1.5 by 0. And to the power 0 is 1. So you'll get 365 365,000, right? Up here. So you're going to put 91.25, right? Is equal to 365 by e to the minus 0.15t. Carry this here. You'll get 91.25 over 365 as e to the minus 0.15t. How much is this?
Minus 1.2.
This is what?
So we take a lot.
So you take ln one time, but it's a quarter. So this is ln of a quarter is equal to ln e minus 0.15 t. Ln e now cancel, so you'll get ln of a quarter all over minus 0.15. Years? 9.2 years? Yeah? 9.2 years? All right. Nice. So that's the end of that modeling thing. I wanted to show you how, if that ever comes, how to handle it, right? Right, so I want you to head up functions from this function. Right? So these are some graphs that we should know. And then all the other graphs that we're going to sketch kind of come from these graphs here. All right? So let's see if we can sketch them. Y equals to X. How does that look? Straight line, right? To the origin, right? Y equals to X, straight to the origin. Y equals to X squared. How does that look? Not starting from the origin. Y equal to X squared looks like this. You ever saw the, I can find that TikTok, but there's somewhere off the picture that I'll show you all these little shapes. How does a cube look? Something like that. Something like a tan. You remember the tan? Something like a tan. 1 on X. We'll pay attention to that just now because this is the one that come the most, right? And e to the X. What does this look like? Yeah, like the exponent. Okay. This one here is one that we had to pay attention to. When X is more than 0, the graph belongs to this function here, to this side here. It has two asymptotes. You know what a asymptote? Right? The curve will come close to it, but never touch it, right? And when X is less than 0, the asymptote is here. The asymptote is the x-axis again. Yeah, these are asymptotes, right? All these here are your asymptotes. Right, there's an asymptote here. Okay, copy them down. And what we're going to learn to do is do some transformations on all of them. We have to learn all the curves. And now we're going to apply transformation to them so that we can draw them without having to memorize those, right? So transformations are things like this. Suppose I said y is equal to minus x squared. What you'll do? Y equal to minus x squared. How will that look? It'll be down. Right? Minus come afterwards, right? If I said x squared plus 2, what will that do? Plus 2 means all the y values add 2. So all the y values will increase by 2. Right? So we're going to look at the transformation and what transformation will do to these graphs. So for example, if I ask you to draw y is equal to 3x squared minus 2x plus 2, this is a transformation of this. All right? A little more complicated, but this is a transformation of this. Okay? So let's take a look at all the transformation. So I want you to write down all these summaries here, and I'm going to show you. And I'm going to show you how to use it, right? But I'm not doing the last one today, right? Because I have to show you modulus first. Right? Write this down. Write this down. All right, nice. So let's apply a few here. So the first transformation, we're just gonna focus on y is equal to x squared, right? So let's see if we can transform example 1. Let's see if we can transform y is equal to 5 minus x squared, right? We need to figure out the transformation to apply to x squared and then sketch it. If you look there, of course, you identify that the main function is this, right? So what are the transformations? I'm just going to write it like this before I apply the transformation, right? So if I write it like this, I'll see in firstly that I have a minus in front here. That's the first transformation. Then they add 5 on the end. Right? So this first transformation says what? Reflection in the X. And this transformation says moving up or down. Up. Right? So you're taking y is equal to x squared and you're reflecting it in the x-axis. Then you're moving it up 1, 2, 3, 4, 5. Right? So the final thing looks like this. So of course, stage 1 is here, right? Stage 1 is here, stage 2, then stage 3. So your function is here. Right? So you start here, you're reflecting the x-axis, and then you move it up 5. Okay? So this is the first transformation, Timothy, and this is the second transformation. That's what the answer looks like. Let's try our next one. Right? For you to do like vertical stretch and horizontal stretches be a little tricky to show, right? So you don't be able to identify it. Let's see if we can sketch this one here. X minus 2 squared plus 5, right? Again, you'll recognize that parent is this one, the one to start from. Okay? Actually, let's do a minus this time. Try that transformation. So what does the minus inside mean? It means the shifting to the right. What does minus 5 on the outside mean? The shifting down. So you're going to shift this 2 to the right and then 5 down. Right? You can't just draw it randomly here. You have to put a point to represent the shift. Right? So I have been shifting the point 0, 0. So in the first example, I shift the point 0, 0 to 0, 5. You have to show me what the shift would be here. Right? What will be the point? So as I said, you're shifting it to the right 2 and down 5. Okay? So I just want to show you what this shift will look like. So the first shift to the right, it looks like this. Right? This point would have been 2. And your second shift, right? This is to the right 2. And this one will be down 5. So you're bringing the whole graph downwards, 1, 2, 3, 4, 5. So the graph might be somewhere here. Right? This point here is 2 minus 5. Right? The y-intercept might be wrong, but I'm not sure what it is. Right? But that's shift good enough then. You okay with that? So from this now, we're going to the main one. This is the one that you will see in exam. All right? So I'm going to ask you a few shifts on this one, and we'll try to see what we get, right? Let's go with number 3. Suppose I ask you to shift. Let's not do too much, right? Let's do y is equal to 1 on x plus 1. What will that be? Of course, you have to watch it and identify what it means for the parent function is, right? So 1 on x means the parent function is this, right? And how are we going to shift it? Right. No, you're going to shift the whole graph 1 up. So you're shifting this, all these curves here, upwards 1. Right? This asymptote stays the same, but this asymptote will go up 1. So that's the first thing I'm going to draw. I'm going to draw the new asymptote here. What's this equation? Right. Cutting it is horizontal, so y is 1. Okay, you move it up 1, right? So the equation of this line is y is 1. The equation of vertical lines is x is whatever the point is. Okay, so y is 1 means you shift in the graph, you get a graph here, and you get a graph.
Okay, always put you on two.
Yeah, always have a simple.
That's really what's kind of X.
Yeah, which I don't give you now. So you always have to have your symptoms. Okay? So the first shift here means 1 upwards, so I change the asymptote to y on 1. By the way, what's the name of this asymptote? What's the equation for this line? Y is 0.
Oh yeah, why is it really?
What's the equation for this line?
0.
Okay? That's the equation. If you remember, a horizontal line is always y is equal to something, and a vertical line is always x equal to something. Squeeze in one more here from us. Y is equal to 1 on x minus 3 plus 1. Right? Y is equal to 1 over x minus 3 plus 1. See if you can do that shift there for me. So this is 1 upwards, this is 3 to the right. For the asymptotes first and then sketch it. Well, we know this one already, right? We know here is y is equal to 1. Clear? What will be the new vertical asymptote? What would the equation be? Minus 3 means it's moving where? Minus 3, it means it's moving to the right. Moving to the right 3. 1, 2, 3. So it's somewhere here. So that is x is equal to 3. Okay? That's okay? So the graph will be here and here. That's okay? Right. I have a big problem here on the sketch list. So this here, we had a particular form that we could actually work with, right? It's not looking like any other one here. But watch this here. If I was to long divide, right? So long divide, x into x is 1. 1 by x is 1 by minus 3 is minus minus. What you'll get here? 0 minus 2 plus 3 is 1. That's it. So you end up with 1 plus 1 over x minus 3. And that's the answer. And that's the answer. That's the remainder. But this is the remainder of what? Of this, right? Watch what? If you have 5 over 12, 5 into 12 is what? 2. Here I get 10. So it's what? 2 and 2 plus, right? Right? Same thing here. Same thing here. Right? This is 1 plus 1 on x minus 3. And this is identical to what? Right? So you shift to the right 3, upwards 1. So now what this really is 1 plus 1 over x minus 3. Right? And this is the graph that we have here. Right? That's this graph here. You shift to the right 3, upwards 1. And it looks like that. All right, that's number 5. So that's that. Let's do one more for me now, please. 3x plus 7 over x plus. All right, so when you long divide, x plus 2 into 3x plus 7, x into 3x's, 3 by x's, 3 by 2. Minus, minus, 0, 1. So your answer is 3 plus 1 over x plus 2. Oh, yeah. I didn't really do any examples with the number on top because it's hard to show here, right? But if you see a 4 on top, you just stretch it, but you can't see it, right? You can't see it because you don't have the original next there, right? So even if I put 4 here, you just, all you do is just say that vertical stretch. Yeah, they can bring it, but you can't really show it. So what does this ship look like, Shavish? 2 where? Shavish, we just went through this boy. 2 to the left and 3 where? So the graph is here and here. Right? The graph is here and here.